And just again, another technical check, making sure that you can hear me properly, you can see me properly, and more importantly, the screen. Everybody good, right? Okay, perfect. So let's get started with our first lesson then. And while I'm doing the lessons, Nathan and David, you might want to monitor any people that may show up and make sure that they are in the attendees list, because we do have a lot of bombing for these sort of events. So anyway, proceeding to the crash course now. So first of all, this lesson 1 is just what is SQL. And well, as they say very rightly, because you've probably heard of what SQL is and what it does, that is why you're here doing this crash course. And there is a lot of debate as to whether it's pronounced SQL or SQL. I had been taught since my very first year in undergrad studies that it was SQL. But I came here and learned that it's actually called SQL. And I don't know how SQL the pronunciation of SQL is SQL, but that's what it is, and that's what we are going to be using right now. So this is just like a little history of that. It was developed by these two guys, Donald Chamberlain. Oh, David, nice. You still pronounce it SQL. That's good. Again, here these guys are saying it's called SQL, but I am probably still going to call it SQL because of 4 years of habit of doing that. So these guys, Donald Chamberlain and Raymond Boyce at IBM, came up with this database programming language in 1970. The 1970s, sorry. And there, I think, some guy, Patrick, actually asked these guys how to pronounce it, and I guess those guys ended up calling it SQL. And so anyway, we now know how to say SQL. So without wasting a lot of time on that, let's see what it actually means. So yes, for Nathan, thank you so much for that. For those who are following along on their own PCs, you would be able to do that using the link that Nathan just sent us on the chat, and that starts off here as well, and you can continue doing the lessons, following them parallelly or just at whatever pace you feel like. So anyway, SQL stands for Structured Query Language, and basically what it is used for is to access some sort of data from the database, to create new data, new tables with rows and columns, and so on and so forth. So because it is of this row and column kind of a structure, it is considered to be a relational database. And that's where the term RDMS or RDBMS comes in, Relational Database Management System. And yes, it as they have rightly mentioned, this still sounds very, very boring. So now that we don't want to bore you a lot with all the theory and all, and make you fall asleep before we even start doing anything, let's actually take a look at what we are going to do in today's class. So there are a few basic commands in SQL which are important for any task related to SQL, and those are select, update, insert, into, delete, some other functions such as sum, count, and average. And one of the more complicated concepts is like joins, where there are quite a few types of joins, which we will soon get to. So when we have a knowledge of how all of this works, they claim that you are ready to become an SQL Grand Master. So who wants to start their journey to becoming an SQL, SQL, whatever, Grand Master? So give me a thumbs up if you're ready to start the first lesson. Perfect. So what we are going to do now is move on to lesson 2. That's it. That's what lesson 1 was. It was just introduction to SQL, and it is pretty much the same for all these lessons. They are pretty much 2 to 3 minutes reading, and then we solve the exercise. So the first thing we are going to learn about today, so Nathan, I'm not quite sure what you mean.
Oh, I was just saying if at any point if you needed a backup, then just tell me.
Oh
I'm
yeah,
here.
absolutely. Yeah, good idea. So if I mess anything up while teaching, just just keep your ears out for that, I suppose. Anyway, so the most important statement in terms of data analysis, the most important command in SQL is going to be your select statement. And what you want to do using select statement is gather some data from a database, from a table that already exists. So yeah, as they say, you don't really have to be an English major to take a wild stab in the dark at what the select statement does. As we already discussed, select lets you get whatever you want from a database, and that's exactly what has been mentioned here. So the first, well, you have that select command, but that's not enough. You want to tell what you want and from where you want that. So just having an idea of what select does is fine. Like, you want to get something, but you need to specify a couple of things at the very least. Yeah, like what do you want to get and which table in the database you want to get it from. So here you have this star character, which is the wildcard character, which is called the wildcard character if I'm not wrong. And as it says, if you're the greedy sort, which basically means if you're very lazy and you just want to view all the columns inside the database, then you use the star. So for the what part of things, if you use star, then that gives you every single column inside that database. So select star is going to get you every column. That's what you need to remember for right now. And after that, you need to specify from where you want to get every single column of from the database. So yeah, Nathan completely agreed. I am also the lazy kind. Select star works for me every single time as well. So as we used in just our plain English sentences, we want to get it from somewhere. That's where the from command comes in as well, which is a part of this select statement. So when you say select star, in this case, because we want every single column, then you want to say from where do you want to get it. So these guys have a table called as customers, and you want to get every single column from that table. That's why you're going to use the command select star from customers in order to get every single column inside that table. So when you do select, you're going to get all the rows by default. And when you do select star, you are going to get all rows as well as all the columns. So that's for this table called as customers. So the next thing which we are going to do is we are going to do an exercise based on what we have just learned. It's quoted as the $1 million keyword, because as they claim, it can add approximately $1 million to your business's earnings or whatever. So yeah, maybe we are not targeting million today, but let's just see how the statement first works. So anyway, what you want to do now is they have given you this database, this table, sorry, which is called as characters. It has 3 columns: ID, name, and alter ego. It's all about the Avengers in here, where the first row is the name is Incredible Hulk, and the alter ego is Bruce Banner, and the same goes for Iron Man and Captain America rows as well. So what I want one of you to do now is, just like we had a select star from customers here, which got us every single column and row from the customers table, I would like one of you to take control and get every single row and column from the characters table. So raise of hands for who wants to go. Idris, perfect. I like that initiative. So let us give you control, and you can take control right about now. Ahmad, did you have a doubt, or did you want to do the coding as well? Feel free to unmute and speak up, or oh, you want to wanted to do the coding as well. So keep your hand raised so that when there's a chance to code again, you will be there on the screen already. So perfect. I think in the meanwhile, what Idris did is code out select star from characters. And now talking about the semicolon at the end, as a Python guy, I tend to forget a lot. So never forget to write the semicolon at the end of the line, as has been done here correctly. So very good job, Idris. Because what happens is, if you want to do a single command, then that will work even without the semicolon. But if you want to run multiple commands, then there has to be a semicolon which acts as the separator for SQL, and that's how it tells one line from another. So please don't forget the semicolon. And I'm sure if you are in one of Nathan's classes, then you will never ever forget a semicolon. You'll probably be putting semicolons in Python as well. So anyway, any doubts about the select statement till now? Anybody? Everybody good? Yeah, absolutely. David is absolutely right. So give me a thumbs up if everybody's fine to move on to the next lesson. Okay, perfect. I see quite a few thumbs ups. So just going to take a sip of water for a second. Has Sydney showed up till now?
No.
So I just read the good one, Nathan. So for the next lesson is what to do if you are not lazy. If you decide to live that fit life, then what exactly do you do when you want to select specific columns? So what we want to do now is learn. So we already learned how to take all the columns from the table, from the table inside the database. And what we want to do now is, instead of using select star to get all the columns, we want to focus our attention on a couple of them, one of them, whatever. And the way we want to do that is by replacing the star with the actual names of columns which are there in the table. So in the customers table, they had the column first name, DOB, email, so on and so forth. But these three are the ones which they actually care about. So what they have done is they have used the select statement, and after that, instead of using star, you have used the column names which are inside the table. And if you want multiple, then you separate them using commas. So very important, you go column name, comma, column name, comma, column name from table name. So that's how you kind of start building the syntax of how you want to go about writing these queries in your head. So you know that the first name is a column name, DOB is a column name, and email is a column name as well. So what it's basically telling you is that when you want to get specific columns, then the way you're going to do that is in this following format, this following syntax, which is select, then column names 1 to n, whatever, like however many columns you want, from whatever the table name is. So now that we have looked at how to select specific columns from a table, we are going to revert our attention to the quiz in here. So now what we want to do is only return the name of our superheroes. So you can see there are these three columns in our table: ID, name, and alter ego. But what if you want to get just the name? Then what is the query that you would write? And Ahmed, since you have already raised your hand from before, I'm going to give you control of the screen and try to come up with a query for the problem statement that has been mentioned. So I guess you can take control now.
Yes, okay.
So although SQL is, or SQL whatever, is not case sensitive, it is usually a good idea to write the keywords in capitals and the stuff relating to the table in lowercase. Forgot to mention that before. That's again just a convention. It won't stop your code from working if you write everything in a lowercase. Nathan, since I can't control my screen right now, could you let someone's in the waiting room? Could you check if they have RSVP'd and let them in? Ahmad, as we discussed, like the keywords and the statements from the SQL are the things for which you would use a uppercase. Everything relating to the table in a lowercase. So the table name is characters, the column name is name, which is why those two would probably go in lowercase according to the convention. Again, it would not have stopped the code from working, but it even makes it look a little nicer than what it would have been otherwise.
Sorry, I just like cannot the column. I don't know because of
the semicolon. I think it's on the same key as colon, but you don't have to press shift. I can help you out with the semicolon. That's fine. If you could just run the SQL now. And there you go. Perfect. You have the right answer. Very well done, Ahmed. I am going to take control back for right now. So anybody with any doubts about selecting a particular column? Everybody good? Give me a thumbs up. Okay, perfect. So let us move on to the next lesson. So now that we know how to get stuff from a table using SQL, we would also probably want to know how to filter stuff out, because sometimes we don't want every single column from the table. We want just every single row, sorry, from the table. We want just a few which satisfy a certain condition. So what's going to happen here is we are going to learn about this clause, which is again a part of the select statement which we have been learning. And what that's going to help us do is it's going to help us filter out these columns based on a certain condition, as we discussed before. So the table which has been used for their demonstration is a table called as products. So as you can see, they want to select all the columns, which is why they have used select star from this table products. But the only rows that they care about are the ones where product type equals book. And that's exactly what has been mentioned here. So product underscore type is another column inside the table which they have, and they are only interested in basically the books which are being held inside that products table, which is why they have given a condition using the where clause and mentioned product underscore type equals book. So what's going to happen is if the products table contains 25 rows, and out of them only 5 of them have the product type book, then only those rows are going to be returned because of this where clause. So what you want to do is what you want to do now is going back to our Avengers character table. So in that table, what we want to do is again use the select statement, and this time we only want to show the rows where the character has red eyes. So we have ID, name, and eyes now in this table. It has changed a little bit. The rows have changed as well. So Thor, Thanos, Captain America, and from that we only want the rows which have red eyes. So who wants to take control? Raise of hands and help us solve this problem. Fatima, perfect. Where are you? And I think Nathan, we have more participants as well.
Yep, I'm on it.
Fatima, I can give you control. There you go. And let's get all the red-eyed people out of the characters table. So make sure to have a space in between select and star. Otherwise, it will try to recognize select star combined as a single keyword. Perfect. Perfect. Let's try to run the SQL command. So very good job, Fatima. Just a couple of things I wanted to go over about this lesson were that when we look at the query which we have written, does anybody have any idea why we are using quotations around red or even book? Any ideas why we are using quotations? Anybody with any guesses? Exactly. So I see quite a few people saying it's a string, it's a text. That is why, and from people who have taken a few programming courses, you'll realize very quickly what a string is. For people who haven't yet taken a programming course, it's basically a text. And because it is text, we need to put it inside a quotation mark to tell SQL that it's the text that we are looking for, not some object which is called book in this case or red in this case. So you need to be careful when doing that. So if, for example, I wanted to filter using ID, then I would go where ID equals 1, 2, or 3 without putting in the quotation marks, because ID in this case is an integer, unless it's a text which looks like an integer, but it's probably an integer. And because it is an integer, you when you are going to use the where clause along with an integer or a float of some sort, which is what ID is, then you are not going to use quotation marks. So be careful about when to use quotation marks and when not to use quotation marks. So any doubts about the where clause? Everybody good till now? Oh, I see. When is an integer not an...
I'm just making stupid jokes, that's all. Just ignore me.
It's okay, you're allowed to make dad jokes. You're a dad of 4. So I know these couple of people that just joined in, so I'm just going to let them in. And moving on to the next lesson. So right now, what we looked at is when we used a where clause, we just basically matched one of the values of one column with something else, like book underscore type product underscore type equals book, or eyes equals red or blue or whatever color we want to filter out. Shirley, do you have any doubts?
Oh, do you want me to mute?
Well, yep. I can hear something in the background. So if you don't mind.
Oh, okay, sure.
Thank you. So yeah, the next thing which we are going to take a look at is not just to filter out stuff that is equal to a certain value, but also use comparison operators like greater than and less than to filter out everything, every value that is greater than, less than, equal to, not equal to, greater than, equal to, or less than, equal to. So I'm sure everybody is aware of these operators, right? So equal to, not equal to is not equal to can be done in two ways, just like in Python, for anybody who's aware, which is either an exclamation mark and an equal to, or a less than sign followed by a greater than sign. Both of these specify that something is not equal to something else. So these are all the comparison operators. So anybody with any doubts about the comparison operators that have been mentioned here? Everybody knows what these do, right? Thumbs up. Everybody who is aware of all of these operators, simple operators. Perfect. So the next thing which we are going to learn is an example with greater than. So again, going back to the products table, which has been mentioned, it would have been better if they had like an example table over there, but since they don't, we are probably going to have to use the power of imagination in order to get an idea of what's going on. So what they're doing is they have this products table, and what they want to do is get all the products which cost more than $10. More than basically means greater than. So what they have done this time around is, again, because they don't really care for selecting particular columns, they have used star. Star specifies all the columns, as we have learned before, from this table called as products, where is again the clause used for filtering out stuff. You're going to use a lot of the where clause in your fancy job as a data analyst whenever you get one. And the column that is of concern to us right now this time around is price, and where price is greater than 10, which basically specifies that anything that has cost more than $10 they are interested in looking at. So all those rows where price is greater than 10 will be returned. So this time for the quiz question, so they have these the same table, I think. No, not the same table. They have the characters table. It's called the same thing, but this time around it has three columns. The first one is ID, the next one is name, and the final one is height. So you have Thanos, Peter Parker, and Tony Stark. So what we want to do is write a query that gets us all the characters with a height greater than 180 centimeters. So who wants to take a shot at that, at the exercise for this one? Daniel, perfect. I am going to give you remote control. There you go. And I guess you can control my screen. So Priyam, you can take the next one if you wanted to take control of this one, or do you have some doubt about this? Okay, you just wanted to take control, that's fine. Oh, that's on me, sorry. I just pressed my mouse by mistake. You can take control again, Daniel, that's on me, sorry. Perfect. Let's try to run the query from the bottom. I think you'll have to just, I can help you actually do that. Yeah, there you go. So if you just run the SQL query now, again, perfect, well done. You have the right answer over there. So this is not the answer, by the way. You need to do the show answer thing for it to actually display the output from the answer. So you can see the correct output in here, which is that Peter Parker was filtered out because Peter Parker is less than 180 centimeters in height, which is why you were left with Thanos and Tony Stark, this row as well as this row. So again, any doubts with what has been going on till now? Everybody good? Still following? Still awake? I know we did expect you guys to stay to wake up before 9 a.m. on a weekend. So thank you for doing that. Actually, I should have said that before. Dylan seems to be sleepy at this point. Oh, just change that. I saw that, Dylan. I saw that. Anyway, thank you for joining regardless. So moving on to the next lesson. So in here now, we are going to get into a little more complicated stuff where is, yeah, so it literally says leveling up our where clause with and. So not quite sure as to how many of you have done anything related to logic design or something like that, but rather than getting into the complicated theory of that, or rather the boring theory of that, not that complicated, let's actually take a look at what happens when we use the and operator along with the where clause. So what we want to do is we want to make sure that whatever rows which are returned satisfy not one this time, but multiple conditions. And we want to make sure that all these conditions are conditions are more fun when there are two or more. Exactly. So we want to make sure that when all of these conditions are satisfied, all of them, in that case we use the and operator. Again, people who have done a little bit of Python or any programming will know what and is, but for anybody else, it is just the fact that you have to satisfy all of the conditions which are joined together by this and operator. So in here they have this table called as holidays, and what they want to do is filter out this time around filter out based on two of the columns, country and holiday type. So what they want to make sure is that they want to get all the holidays which are in the country of Spain, and also the holiday type is a beach holiday. So it wouldn't matter if only one of these conditions is satisfied, that would still be filtered out of the program. Like if it was a Spanish holiday but it was not a beach holiday, it will be filtered out. If it was a beach holiday outside of Spain, that would also be filtered out. So the and operator makes it mandatory for the row which you want for the to be satisfying all the conditions mentioned in there. That's the main focus of the and operator. I can't stress enough on that. Anyway, so again, same thing for you. When you want the returned values or the returned rows to satisfy more than one condition, you use the and operator. And what you want to do with our characters table this time around is we want to be very specific what we return. Yeah, okay. Write a query that only brings back black-haired females from our character table. So we have this table in here, which is now growing a little bit in size in terms of columns as well as rows. It's called characters once again. It has ID, it has name, gender, and hair. So when they are talking about black-haired females, how would you transform that into a SQL query? So since Priyam had already raised her hand before, I am going to give her control and let's see what she comes up with. Perfect. Perfect. one tiny little thing to go. Okay, perfect. That's good. You can format it the correct way as well. Perfect. There we go. Nathan's happy. Now we can run our query. And if you just do show answer for us. And as you can see, I'm just going to take control back now. As you can see, Jessica Jones is the only row in here, or the row with the name Jessica Jones is the only row in here, ID 3, who has the gender female as well as black hair. So since this is the only row which satisfied both the conditions, that's the only row which was returned. So again, any doubts before we move on to the next lesson? We are already almost at lesson 7. So any doubts with using the AND operator now? Yeah, good. Everybody good? Thumbs up. Still good and awake? Perfect, perfect. That's what I like. So moving on to our next lesson. So just like we studied about the AND operator, now it's time to study about the OR operator. So the main difference between AND and OR, both of these are actually used to give multiple conditions, but the main difference is that with AND, the filter acts in such a way that you need to satisfy all of these conditions, and in case of OR, you only need to satisfy one of these conditions. So in the case of the holidays table again, which they have mentioned in here, what they are trying to do now is filter out all the holidays where country is Spain or Portugal or Greece. Even in plain English, when we say or, we mean that either one of these is fine, which means that if either one of these conditions is satisfied, then it is going to return that row. So no real exercise for this one, but just an addition on top of what we studied with AND. The format is the exact same. Just the difference is that when you are using the OR operator, only one of these conditions needs to be satisfied. So again, everybody clear with the use of the OR operator and the difference between the AND and OR operator? Everybody good? Yeah? Okay, perfect. Yeah, Idris.
Sorry, I think it was the previous hand raising. Let me just lower it down.
Oh, okay.
Sorry.
Okay, sorry. Did not notice that. So the next thing which we are going to learn is the use of the in operator. Again, as you might have started noticing by now, we are using the where clause along with all these operators, just further emphasizing the importance of the where clause and the select statement in your life as a SQL database person. Just give me Nathan, if you can take control for a couple of lessons, because I actually have to charge my laptop and my charger is downstairs. Just give me a second.
All right. Oh no, I don't have control. There we go. That's better. All right, so the next thing that we can do is we can look at when we're creating the where statements. And in this case, perhaps maybe we want to show multiple countries in our results. So in this case, the example is showing us that we want to select all of the rows. We want all of the columns because we're doing select star. And what we're looking for specifically is that we would like all of the holidays. But we want the holidays that are for 3 different countries. So we have Spain, Portugal, and Greece. And so what we can do is we can use the in keyword with round brackets, and then we can provide a comma-separated list of literal strings. And this would give us the results that would be equivalent to us saying where country equals Spain, or country equals Portugal, or country equals Greece. And yeah, so if you're using a concatenate statement, the syntax of this is very similar. But the functionality of the in versus concatenate is different, but the syntax that you use is very similar. So down here, we'd like to use in to bring back the results where everyone... Didn't we do this one? We just did this one, right? We did this one 2 seconds ago. But
I don't believe
we did
so.
it. But we did it a little different, right?
Oh yeah.
We did or throughout. Now, because I can't give up control of Aditya's computer, what I'll do is I'll type it here. Maybe. He's moving his mouse.
Okay, I'm back. I can.
Oh, there we go. Okay.
To someone.
Okay.
Sorry.
So we're at the point where someone can ask to remote control the screen.
Yeah, I've been back for a second.
Okay.
So, good timing, I suppose. So raise of hands who wants to take control and find out anyone with black or brown hair using the in keyword this time around. Priyam, since you just went, I think I would like someone new, preferably for every lesson, but if not, then you can take control again. So anybody who hasn't gone till now, as I keep saying in all my classes as well, practice is probably what is going to help you become that Grand Master that they claim. So Dylan and Ryan and Vishal. Okay, so in this order, you will go for the next 3 rounds. So keep your hands raised, giving the control to Dylan for right now, and let's see what you come up with there. So, you're missing the opening. Yeah, there you go. Parenthesis.
What am I doing? Okay, there we go.
Yeah, there you go.
Everything has like a leg to it, and it's so weird to click.
Yep, but you got it now.
Alright.
Let's do the show, or I can just take control. That's fine. Stop remote control, and if we show the answer now, and Nathan, again, I think we have some more participants joining in. If we show the answer now, as you can see, the values that have been returned, the rows that have been returned are ID 234, the Wasp, Jessica Jones, and Hawkeye, because all of them either have brown hair or black hair. So is everybody clear with lesson 8 now, using the in operator? Just makes your life a little easier than having to use OR 55 times. Everybody good?
Sorry, I have a question.
Yeah, go ahead.
Okay, and it has to do with the proper indentation for each of the clauses within these select statements.
That is a very good question. What I'm going to actually do is, I think I need to refresh this before I can write a query again. So, okay. So, Python, and I'm sure you have done Python here in my class. Python is a programming language where indentation actually is so important that without the wrong indentation, your program either does not work or messes up how it is, or does not work as it's supposed to. But what's happening now is that in case of SQL, or I think most, if not all languages apart from Python, indentation is not mandatory. You can indent it any way you want to, and it should still work. But I guess the convention would be to first of all have in case of select statement, first of all have the keyword select, have the statement name in here, and the column names. So either column names or star. Like if you want all the columns, then star. Otherwise, whatever columns you actually want, like ID, name, so on and so forth. So you would have that in your first row, so to speak. Then you would have from where do you want to get that? The table from characters. That would be your second row. And I think anything in the where clause should be in the third row when writing your query. Again, that's just a convention, so to speak. It won't break your program if you do everything in a single line, if you don't maintain the kind of cases that they have done in here, because SQL again is not case sensitive. So where country in, and then we not country, sorry, this time we wanted hair in I think only black or brown, so black, brown. I think this was the query which we did, and then a semicolon, of course, which I will tend to forget, and Nathan won't. So anyway, this would I guess this would be the convention for writing the SQL query. David and Nathan, you can feel free to make any changes or any additions to what I said. They have worked much longer in the actual industry, so I would suggest that this is the way to do it. So do you agree, guys?
Yeah, looks good to me. When the queries get a little bit more complicated, I have some tips, but I'm just waiting until they get a little bit more.
Yeah. Okay.
I usually do an indentation for some of these, but my indentation methods are sometimes kind of weird. So for now, keeping them flat is fine.
Okay, so yeah, like as we are discussing, it still doesn't break the code or anything. It will still work, and I guess there's not just one single way to write these queries because of the fact that it actually works. So yeah, people have different ways of doing that, and I guess when the queries get more complicated, that's when all these methods will start showing up in your code as well. But for right now, this would be probably the one of the ways to do it. So does that answer your question, Idris?
Yes, I'm fine. You know, during our classes, our lecturer emphasizes the proper indentation, and in our assignments, if not properly done in line with how he has taught us, it tends to deduct our marks. You know, so that's why I wanted to be sure if, apart from the fact that it doesn't break our code, you know, if based on best practice, there is an ideal way of doing it. But I'm clear with your explanation. So thank you.
Okay, perfect. So, but if for any reason, like when you're taking your course, if your grades are getting deducted, then I would recommend not to fight that and just stick with whatever your instructor is telling you to do. Because I'm sure even they have worked in the industry and they have an idea of what's going on as well. So for your class, I would say stick to that kind of indentation.
Generally, my experience when I'm the instructor, and I think this is the case with the other instructors as well, but obviously everybody teaches a little bit different. As long as the query produces the result that I asked for, if that was the goal of the question, then I'm happy with it. But if the goal of the question is, I would like you to format it this specific way, then that's when I would be looking for that. But usually I would try to be specific about what I was looking for.
Perfect. Again, I think we have a few more attendees in the waiting room, and anybody with any other doubts about anything that has been done till now? Everybody good to move on? Actually, that's what I thought, but it's not the case. Sometimes when the queries are longer and more complicated, indentation is difficult. Yeah, that's kind of that's kind of natural because well, first of all, they are longer, and it's then sometimes up to what actually makes it look sensible, makes it look good, and not like a mess while typing out the query. But if you have been explicitly instructed to do it in a format, then I would suggest just blindly stick to that. Anyway, so moving on to the next lesson. So we looked at the AND operator, we looked at the OR operator. Now we are going to take a look at the NOT operator again to go with your where clause. So what we want to do now is, instead of filtering out stuff which we actually want, we want to filter out stuff based on what we don't want. So here they have given us a very nice example where they say that we want to go for a holiday, especially as people who are living in Canada, we want to go on a holiday to a place which is sunny, and that's not going to be possible if we go for a holiday in the North Pole or the South Pole. And that's why what they have done is they have filtered out the column country to specify that country should not be in North Pole or South Pole. So there technically aren't any countries called North Pole and South Pole, but still we just wanted to make sure. And that's why we are putting in this this not operator to go along with the where clause. So what's happening here is that star specifies all the columns are being taken from this table holidays, and they want to make sure that country is not, again, just like we would use in English, not in North Pole or South Pole. Not in again specifies that if it is in I mean, if it is one of North Pole or South Pole, then you take it out by using this not. Not is basically like a flip. It takes zero, like it makes 0 a 1 and 1 a 0 effectively. So let us move on to, so there is another no, so there isn't another quiz in here. So yeah, here they have also explained what we have to do in order to write a query. Basically, what we are asking right now is for all the columns from this holidays table where country is not either North Pole nor the South Pole. So yeah, wherever the country is either North Pole or South Pole, those kinds of holiday packages will be excluded from the rows which are returned. Yeah, we have told what we wanted, where we want it from, and been specific about which subgroup of the wider group we do not want to see. So again, as people living in Canada, we would probably want to go for a holiday in some place like the Caribbean or Florida or something like that, and not, I don't know, Nunavut or whatever. So so that's basically what we are doing in here. So not, as I mentioned before, is just like a flip. Oh, so David tends to, yeah, so David wants to go to Nunavut. All the best to you. I think that would be too cold for me. It is still shorts weather in Sudbury. So yeah, maybe I was actually wrong. So people in Canada are actually more prone or resistant to cold, so maybe they want to go to colder places. But as of someone like me who's moved from actually a pretty warm place and finds Sudbury itself cold as hell, I do not want to go further colder, so I will probably be looking to go someplace warm. So anyone who shares that view with me will probably want to not go to the North Pole or South Pole. So anyway, everybody clear with the use of the not operator? Everybody good? Okay.
Yeah, sir, I
Yeah.
have one question regarding select command.
Yeah.
Suppose we have like 10 rows, and if we want to select 8 columns, 10 columns, and we want to exclude 2 of them. So we need to write 8 columns in the select command, right? The name of the 8 columns.
Yeah. So based on what we have learned, right? Yeah. That's what you would probably want to do. Like in the select, again, correct me if I'm wrong, Nathan, but I don't think you can do select not in or something like that to just exclude 2 columns rather than include 8 columns.
Well, I mean, you can, but you need to be able to very distinctly determine what it is that you want to exclude, and then you have to be 100% sure that what you're excluding will produce the result that you do actually want. So if you're selecting from a table that's very static, like maybe a list of statuses or something like that, where you know there's a finite number of rows, then doing an exclusion might work. But selecting from, let's say, a products list or customers list where it's ever changing, then that might become a problem.
Could you select all and then alter the table to drop the column that you don't want?
So yeah, I think Nathan, he was talking about selecting
you mean the columns?
Yeah.
Okay.
Yeah.
So wait, yeah. So you could do a subquery to do that. So there's I think it's beyond the scope of this session, but you could do a query, and then you can put that inside another query, and then that can change which columns you want. What you can do as well is you can select to a temp table, and that temp table will only exist during the period that this query is in execution, and that's using a select into statement.
Okay,
Yeah,
because
I've done
like
exactly
I'm
that.
thinking that suppose if we have like 50 columns and we just need 40 out of 50, so what should we do at that time?
Can you think of a scenario where you would need to do that? I'm just wondering if there's an example that might make it easier to explain.
Not sure, but maybe in some financial statement, like some document related to finance, there will be a lot of information available.
So in that case, I think you could accomplish it with just the normal column list that exists within the select. So you can do select. In this case, we have select star from holidays. So you would go select first column, comma, second column, comma, third column, and so on. And that'll give you the columns that you want. But I can't think of a way that you could selectively subtract columns in that way.
Yeah, that's what I was wondering too, actually.
Yeah.
It probably will be tedious, but so top 40 would work for the rows and not the columns, if I'm not wrong. Could we actually?
So that's for the rows, yeah. So top will give you the rows.
Yeah.
Actually, you know what? I
actually,
just
that's
thought of a
what
way you
he
could do it.
said,
I'll
that-
find it.
Sorry.
If you
I
look at
guess
the chat, this is what's worked for me before. Oh, I sent it to Nathan only. Whoops.
Sure. I'm clicking the select data button. And in the select data source dialog box, I'm clicking the add button.
I don't know how well that describes what I'm trying to say, but I've used that before and it's worked pretty well.
Again, I was trying to think from the perspective of what's in the scope of this crash course. So to that extent, I would what you have done will definitely work. Yeah, it will work, but not quite sure if we can include all that in the. I don't think it's in the scope of this class which we are doing right now, and of course, and it's not that we are discouraging people from using anything that's not in the scope, but right now we have to get that done first, and then on top of that you can probably even build onto that knowledge by taking a few courses of your own. I think W3 Schools has an SQL course as well, which will probably build on top of what you have learned in here as well. So eventually when you do get to that level, then yeah, something like dropping the dropping like a list of columns or something would work. But for right now, I think as someone who's right now a beginner right now, we would suggest you probably stick to the tedious way of including 40 columns out of 50. Yeah, I think Nathan is on it for the examples. So lesson 10 now. So what we want to do next is we want to take a look at wildcard comparisons using like. So what does that mean? So so when you want to filter out, again, we are still talking about the select statement, we are still talking about the where clause, but this time around, instead of filtering it out based on something that's equal to, greater than, less than, so on and so forth, we want to find every entry inside any particular column, multiple columns, whatever, which match a particular pattern. So before moving on, I see quite a few videos frozen. Can you guys see me right now properly and the screen as well? Just give me a thumbs up.
It's my webcam that froze. I think you're fine.
Okay, perfect. So that's good. So when we want to match a pattern, okay, there we go, of some sort, that's when we want to put in some kind of wildcard characters. So again, wildcard can basically mean any character whatsoever, and there are mainly two wildcard characters that we should concern ourselves with. The % symbol specifies that from that point onwards, or until that point, you can have as whatever number of whatever character that you want, and in case of the underscore, that stands for, again, it can be whatever character, but the number of characters are determined based on how many underscores are there. So if you use one underscore, then that would be one wildcard character in that particular place. And if you use two, then it will be two, so on and so forth. So again, rather than confusing you more with the theory, let's take a look at an example which they have mentioned in here. So so they have a table called as bands, and there is a field which again, field is just another way to say column, that's called as band name. So this table has musical bands with color themed names. So there is the Blue Tones, Black Flag, Green Day, Deacon Blue, Yellow Card, and the Blue Notes. So if we only want to return those with the string blue in their names, and had to use the basic comparison operator. So we are still not reaching the wildcard. We are trying to solve this by using just the basic comparison operators like greater than, less than, equal to, so on and so forth. So what we would have to do is something like this. We would have to specify one of the values inside your column and compare based on that. So band name equals the Blue Tones, or or Deacon Blue, or the Blue Notes. That's what we would have to specify in there. But what we can do with the like operator is, by using the pattern matching which we discussed before, we can get with the help of the like operator as well. Yeah. So with that, what we can do is where is it? Oh yeah. So with that, what we can do is we can compare it with a pattern, and this is where you'll see what I mean by the wildcard character. So instead of doing it this way, where you have to specify one particular band name, we can be like, so select star from bands, which is the table, where band name, which is the field, column, whatever you want to call it, like, and then we specify the pattern. So here you can see the pattern is % blue %. So what that means is, blue is the string which we want to focus on, and the percent before and after means that there can be any number of characters before blue and any number of characters after blue. So anything that matches that particular pattern is going to be returned when we run that query. So the results are going to be the blue tones, deacon blue, and the blue nodes. So let's try to see how those match this pattern in here. So Vishal and Ryan, have you raised your hand from before because you want to do the exercise, or do you have some doubts right now?
No,
I
for
have
the
a question.
Yeah.
Like you mentioned something about pattern matching, and like where we search for the answer with the string blue. Can we do the same thing if with the small letter B instead of capital letter B?
Yeah, absolutely.
I mean,
So it is the pattern is also a string, so it will try to match the exact string which is in there. Like if we do blue right now, then it won't return the same results, because even if SQL itself is not case sensitive, the string and the value which the computer recognizes as capital B and small b is not the same. So if you do small b there, then it shouldn't return the same value. It will probably return nothing because there is no blue with a small b in there. But again, going back to analyzing how these things match this pattern. So our pattern is %blue %, which means any number of characters, then this string blue, and then again any number of characters after blue. So because we have this string blue, first of all, that's what is going to be checked, if blue is present in that string. So blue is here, blue is also here, and blue is also here. So in case of the first one, blue is here, and there are 4 characters before blue, which are T, H, E, and space. And after blue, there are 1, 2, 3, 4, 5 characters, which are T, O, N, E, S. Again, when we use %, the number of characters does not matter. And also, because they are all wildcard characters, which actual characters they are, that does not matter either. So what we are going to do is specify that with the help of %. That's why the first one matched the pattern %blue %. In case of the second one, it also matched the pattern, and let me explain why. Because % before, again, 1, 2, 3, 4, 5, 6, 7. These are the 7 characters which were before blue, and those were D, E, A, C, O, N space. Then it was blue, and there is nothing after blue, but that's okay too. When we specify %, there can also be 0 characters after the string which we are matching, and that works fine as well. % may also mean 0 characters. It is anywhere between 0 to whatever, like infinite number of characters that may be matched. So that's why even after blue, even if there is nothing in the string, that's still okay. It's still considered as a match for this pattern. Then the last one is pretty similar to the first one, where blue is a string, THE space are the characters before that, and space NOTES are the characters after that, which is why that has matched this pattern as well. So before we move on to anything else, is everybody clear with what like did and how these results matched this pattern? Thumbs up, everybody good?
Sorry, I just joined right now, so probably if I can get the video probably later, I'll go through it. Is it good? So I don't drag everyone back.
Yep, and also I pasted a link in the chat that you can go to, and then you can see everything that we've done so far.
All right, thank you very much.
Yeah, so if the first 8 or 9 lessons, the first 9 lessons, again, because we did a lot of explanation and stuff like that, it took as long as it did. But I'm sure you'll catch up pretty soon. So we have all of that, and the next option which we have is using blue %, and what that means is that blue will have to BLUE with capital B will have to be the first 4 characters in the string, and then you will need to have any number of characters after blue, because there is no % before blue. There shouldn't be anything before blue as well, and this will return 0 results because all of these do not have the string blue at the beginning, and that's why this will return absolutely nothing. And then yeah, the next wildcard option is, instead of using %, we use underscore. And as we mentioned, the difference between % and underscore is that when we use %, there can be any number of characters before or after wherever we have specified. Like in %blue, here, there can be 0 to infinite characters, then the string blue, and then again 0 to infinite characters. But in case of underscores, it has to be exactly the whatever number of characters has been specified in here. So I can't exactly count how many characters this is. I guess it's 10 characters, as you can see in here. So if we want to basically return any band name which has 10 characters in it, then what we would do is we would use underscores. You can also use that along with a string. So for example, if we wanted to find something that had 1, 2, 3, 4, 5, 6, 7 characters before blue, then you can be like underscore 7 times and then blue, and that's how you would match. Like that would match with Deacon blue. That would be the pattern that Deacon blue actually matches, which is why that will be the result returned. 7 underscores and a blue after that. So I think since we are at 10 lessons, now is when... Oh, can you repeat for blue person? Yes, absolutely. So, who was it? Vishal. Yeah. So Vishal, are you clear about %blue before we move on to that?
Yes, it's clear.
Perfect. So when you use blue % instead of %, it takes away the first %, which means that there cannot be any characters before blue, before the string blue, in case of blue %. So % is the only wildcard character, and it is after blue in this case, which means that before the B, there can be absolutely nothing in the band name column value. So because of that, you will get 0 results, because if you check this, then none of these names begin with the string BLUE, which is why it won't give you back any names. Does that help you understand it better?
Yes.
Okay, perfect. So since it is past 10:15, I think that's when we were supposed to have our little networking break. How about we start in 15 minutes from right now, and until then, feel free to talk to anybody on chat, or just unmute yourself, speak up if anyone wants to talk about anything. Feel free to do that. If anyone wants to just introduce themselves, what you have been doing, so on and so forth, feel free to take the stage, because we have a 15-minute networking break starting right now. So 10:36 is when we will be starting our class again. So if anyone has any ideas for what we can do in this 15-minute thing, Nathan, David, feel free to do that as well. Coffee, that's a good idea. Yeah, but this is like a virtual coffee meeting, so if anybody wants to share anything, feel free to do that. I'm just going to stop talking myself right now.
Okay, I want to say something.
Yeah.
Okay, actually, there are a lot of people in this forum, and I don't know a lot of people in Canada. I'm new here. I'm looking for a job. basically part-time for now. And I also have a career gap, but it was not so much of a career gap because I was working as a volunteer in US for a startup firm. So if anybody has an opening or if they want to give me a chance to work with them to showcase my skills, I would really appreciate it.
All right. Well, we'll leave that question open to the floor, and if anyone wants to send a message in the chat or anything of any kind of opportunity that you know of, then please feel free to do that.
Yeah, and you can be sure that she'll do a good job. She's one of my students and has been doing well in the course as well. So yeah, she has my recommendation from here. So feel free to text her. I mean, you put it on chat if you're aware of something, as Nathan already mentioned.
For those that were interested in how to figure out how to select from a variety of columns that we were subtracting the columns, I do have a working example here. So again, this is outside of the scope of this session, but I'll share my screen for a moment, and anyone who's interested in doing that, then I'll show you what I was able to figure out.
I think you can, and I'll be back in a couple of minutes.
There we go. So so again, this is an example specifically for those people who are wondering when we're selecting columns, how can, normally we would specify which ones we want, but maybe we want to selectively remove columns. So what I'll do is I'll give you an example here. This is one that I use in my class. So there's this database here called My Guitar Shop, and the way that it works is inside this sample database, I can see that there are a variety of columns here. So I have customer ID, an email address, password, first name, last name, and then some shipping information. And normally what would happen is I would create a select statement here. So just like we've been doing, I can say select star from, and then the table that I want, just like this. And this is no different than anything we've been doing so far. And I run that query, and I can see these are the results. So again, I'm in a different program than we're using here during the session, but same idea. And normally what you would do is you would say, let's say you want the customer ID, and then you would like the email address, and then you would like the first name, last name. So these are the columns that I'm looking for. And I would write the query something like this. And again, pressing enter, putting things on new lines, tabbing them in, has no impact on how the computer recognizes the query. That is just for us squishy humans who don't understand code as well as the computer does. So it makes it a little bit easier for us to see what's going on. But you can see here I've selected 4 columns, and so now I am excluding the billing address, the shipping address, and the password from my results. But I'm doing this by specifying the columns that I do want, right? But the question that we had posed earlier is it possible to, instead of specifying the columns I do want, is it possible to specify the columns that I don't want? So instead of doing this, I would want to somehow tell the code, what columns do I want? Well, I don't not password, right? And not, shipping address, ID. And this is garbage code. I'm not writing real code. This would never work, what I'm doing right here. But it's essentially something like this, where instead of specifying which columns I want, I'm specifying the columns that I don't want. Now, you can't do what I just did. This is completely made up and fictitious. I'll show you how you can do it. Now, again, this is way beyond the scope of this session, but this is what I came up with over the last few minutes. So you can create a variable, so just a spot to hold in this case, a literal string. So if you could think about it, what I need is I need a list of all of the columns that I want. So I thought about this and I thought, well, if I just open up a new window here, I have this list of columns right here. I can ask the database, I can write a query to ask the database, hey, what columns exist inside this database? And I can say, select the column name from here. So let me simplify this a little bit. So I'll just go like this, go like this, and I go like this. Select the column name from, basically right here, I'm asking the database about information about the database. And what's the database called? In this case, my example is called My Guitar Shop. And what table am I asking about? The customers table. So if I run this, I get the list of columns. All right, I've got something, right? So let's take a look at what I had again. And I'm just gonna tack on this extra little piece here. Where the column name is not in. So this is the same thing we just did with the, I think it was black hair and some other attribute, I can't remember. Same idea, right? So I'd like to exclude password and shipping address and billing address. So if you look here, this is the result I had. And I'll run this. Oops, run this. And see now I only have the columns that don't match this. So now I've essentially done what we've kind of been looking for, is I've excluded columns from the list. But when we're creating our queries, let me just jump back to my example here. We need to come up with something like this. Now, I pressed enter to make it easier for us to see, but let's just, I'll put it back on one line, maybe try and make it a little bit. If you look at that, it's just a list of the columns that we want. And if you look at the result I got here, it's close, but I just need it to be on one line, right? I need to get this to look like, sorry, I have too many windows open. I lost my way. There we go. I need to get my result to look like this. And so what I can do is I can come over here and there's this little extra piece that I have written here. And I can go like this. So group concat. So I'm going to concatenate them together and I'm going to group them. So if I run this, now my result looks a little bit similar. So if I compare this with, where was I? This one? With this, that's what I'm looking to do. So if I take all of this, I can take the result of this and I can make a variable that's going to hold a literal string. And I'm going to set its value to be equal to the result of that exact query, that query that I just ran in the other window. So this query right here, and this is the result. So I'm going to have this variable called columns that's going to be equal to all of the columns that I do want separated by commas. And then down here, I'm going to make myself another variable. So this piece here is its own component. I make another variable here, and it's going to be equal to select with a space all of the columns that I found, space from customers. So if I look here, let's just put all this on one line so it looks similar to what we would be creating. Like that. Select all of my columns from customers. So that's essentially what I'm building. And then I tell the database to execute this. And what I can do is run this, and I get the result that I expect. Let's say I do want the password. So I don't want to exclude the password. Just take it out of my not list right here. And now I get the password. And then if I want to have the shipping address, I can do that. Or I can put them back. And I can edit with this. And maybe perhaps I don't want the email address. Just like that. So there you go. To the side question that we had at the beginning, to can you selectively remove? Does that answer your question?
Yeah. Thank you so much for the explanation.
So what I'll do is I'll paste that in the chat, just in case anybody wants to see that.
Yeah.
And you can copy that. Now it's very specific to the database that I'm using here, but hopefully that gives you an idea as to how that works.
It's pretty interesting, like tricky and interesting both at the same time.
Yeah, like I would say, even so, the SQL course that I'm teaching now, and then even the SQL course that I teach at the graduate level, we don't necessarily do that. It doesn't come up very often.
Okay. So in practical, in real world example, there is no need for this kind of things, right?
Actually, it does come up. We've had, so many years ago, I had a software development company, and one of my employees was very good at SQL queries, and he would do things like this regularly, because we did have complex queries that would do things like this. Now, you could you would do things like this. You would do combinations of this, maybe with grouping, or you would do multiple queries and then you would join them together, or you can I mean, we're all over the map. But this employee of mine would write queries that that would be pages long. And, you know, it's dependent on the purpose of what you're trying to do. So what I'll do is I'll stop sharing my screen, and we'll wait. We'll start again in about 2 minutes. But I'll just I'll pause and I'll mute for 2 minutes. If anyone wants to talk in the chat among yourselves, then that's fine, and we'll start again in a moment.
When going through the chats, I just saw one question, which I'm not sure if it was answered. Idris asked, does anyone have an idea on application of SQL in internal audit? So I would think that many of your KPIs could be monitored by I don't know, like writing a few queries and making sure that everything that has been brought in and like all the stuff actually is what you are expecting it to produce, and so on and so forth. Like your KPIs are met, and that can be verified by querying your database for any related like incomes and so on and so forth. So yeah, like there is an application for like having SQL and databases in pretty much any field out there. I hope that helped. So now that it is 10:36, so give me a thumbs up first of all if you guys are back from your break. Everybody there? Perfect.
So would you like me to do the next section?
I was thinking from lesson 14. Like we are on 10 right now, so I was thinking from 14 maybe.
Okay. So I'm just trying to fix my camera. So
yeah,
I'll do that, and you continue, and then we'll switch then.
Okay. Yes, okay. So Ryan, there won't be a certificate per se, but I think you can include that in your co-curricular record on which appears in your Cambrian transcript, if I'm not wrong. And I think you need to just fill out a Google form of some sort for that. And of course, you can say that you have attended Google Developer Group events wherever. So, but no, like there won't be an official certification or something of that sort after this. So moving on to the next piece. So again, just making sure that everybody can see my screen. Give me a thumbs up if everybody can see my screen. Okay, perfect. So moving on to lesson 11 now. So yes, as handling dates, that is the next thing which we are going to take a look at. So as they have very rightly put in there, dates are the devil, literally. So yes, the thing they're talking about is not the dry fruit, but well, I don't know why this person thinks that dates are gross, but I actually like them quite a lot. But we are talking about dates in terms of temporal dates, like time, 1st July 2019 or something like that. So as you already must know, especially if you have come to Canada from somewhere in the East, that there are 1,000 different ways to write a date. So there is a format where you have to write the day, the month, and then the year, or month, day, and year, or year, month, day, year, day, month. But like, there are so many formats. Sometimes you just actually write down the month, like August to 1997 or something like that. So in that case, there is a lot of inconsistency introduced when we have so many formats, which is what actually makes it very tricky to handle. It's not necessarily difficult, but kind of tricky. So what we are going to do is follow this particular format, and as they have very rightly mentioned, we are going to pretend that all the dates are in this YYYYMMDD format. So basically, first of all, they'll mention the year, then the month, and then the day separated by these dashes. So yeah, as that's what they have mentioned in here. 14th June 1978 would be 1978-06-14. So yes, SQL example, please, as they have mentioned rightly in there. So what they want to do now is they want to find the customers using their customers table who were born before the turn of the millennium, which means that the date of birth should be before 1st of January 2000. And the way to put it in an SQL query is something like this. So this time they're interested in just the 3 columns, first name, DOB, and email from this table called customers. And the condition is going to be where DOB, which is date of birth, less than 200101, which is again 1st of January 2000. So what less than does in terms of dates is it basically tells you whether the date is before or after. If the date needs to be before, then you use less than. If the date needs to be after, then you use greater than. And that's kind of how we would go about checking these dates. So again, what they are asking in here is for the first name, date of birth, and email address for all customers with a date of birth before 1st of January 2000, as we already discussed before. So now for an exercise, finally, I think Vishal had to go and someone else had to go after him, Ryan, if I'm not wrong. So so let's imagine it's New Year's Eve 2012 and we want to watch a Robert Downey Jr. movie. So what we want to do is we have this table called as movies, and what we want to do is we wanted to return all the Iron Man movies which were released before 31st of December 2012. Make sure to follow this format and let's see if you come up with a query for a query to solve this problem. So I think Vishal was second in line, so I'm going to give him control and let's see what you come up with right there. Perfect. The table name is movies, as has been mentioned on top there. Now take a look at which column we are interested in. And make sure that that column is actually present in the table movies this time around. Perfect, there you go. Again, we are talking about before whatever date is mentioned. Perfect, that's why we use the less than symbol. Then the month, so 12, perfect. 31. And what's up with that? I don't see anything wrong with that. Try to run it. Maybe it's like a grammatical error or something, which is why it's, yeah, there we go. I think it was my Grammarly or something acting up because it's not grammatically accurate. So when we do the show answer thingy, that's how we would get Iron Man and Iron Man 2 because both of them were released before 31st of December 2012, and that's why this one was left out. That's how we would work with dates. So date, even though it looks like a string, is actually a different data type in SQL. And that's why it was actually able to compare dates as in less than, greater than, so on and so forth. That's also something that needs to have quotations around it. Yeah, so that's why it might have felt as if we were using a less than with a string, which doesn't really make sense, but that's not what that was. This date is actually of the data type called as date. So that's why we got these two entries which have been released before 2012. So any doubts with lesson 11, handling dates? Yes, Krishna.
Yes, for this one, actually, say, for example, the database stores the date in this particular format, year, month, and date. So, I mean, only these kind of queries can be addressed by these dates. Like, I mean, if the dates are stored in some other format, will the query be able to handle that?
Yeah, so the way right now we are basically assuming that all the dates work this way, but that's not the case. In that case, you have to do a little bit of research. You can like just do a random select star from whatever table you are interested in. Just get an idea of what the format of dates is in there. It can be like this, it can be DDMMYY, it can be one of 1,000 different things, and that is what the format you will have to use when when trying to write a query for that particular table.
Right, I get that. Okay, right, thank you.
Perfect. So good to move on to the next lesson then. Thumbs up. Okay, perfect. Let us move on. So, another thing which we need to do in general as a programmer, as someone who's working with databases as well, is to have as less redundancy as possible. That's not exactly the principle that applies here, but basically what we want to do is, let's say we have we have some results generated, but we want to remove all the duplicates from that result. So let's say we only take one column. In that case, there are many chances. There's a good chance that there will be many duplicates. And in that case, if we don't want all these duplicates, then we just add one little thing, one little keyword to your select statement, which is distinct. And what distinct does is it shows you a distinct set of all the things that have been returned. And yeah, so that's why you would be getting just one of each of the values present in there. So let's say we have this column which we have taken out, which is called as names, and maybe that has like Adi, Nathan and David, for example. Then what distinct is going to do is, because Nathan has been entered twice, it's going to get only one instance of that, and then the distinct is going to return the column which is Adi, Nathan and David, and that's it. So I'm sure they have one example in here as well. Yeah, there we go. So they have this example called surname from player names. So that means that all the surnames will be returned, like one instance of all the surnames which are present inside player names will be returned. So player names again is a table, and distinct is going to return one instance of all of the surnames. So duplicates be gone. That's the whole point of this. So the quiz time now again. So this time around, Ryan, I think you have to go next. So this time around, they say ICE are at the door of the Avengers Tower and they want to see some paperwork of all things. I hear a little bit of static coming from somewhere. I don't know who's unmuted right now, but I would request you to mute while we are teaching. Thank you so much. And yes, so in that paperwork, what they want is what is the distinct list of different nationalities of the characters in the Avengers Tower. So at that point, we have Thor, Loki, Captain America, Black Widow, Iron Man, Peter Parker, and Wong inside the Avengers Tower, and their nationalities are Asgardian, American, Russian, so on and so forth, respectively. And now you want to get a distinct list of all these nationalities. So again, you probably would have noticed that you're probably going to use distinct with just one column, since it otherwise may be an inconsistent size of list. Like in case of names, there are more distinct names than there are nationalities, so just use that with one particular column. So Ryan, I'm going to give you control and get the distinct list of nationalities from that table called as characters. So let's give you control. Where are you? There you go. And yes, go ahead. Ryan, are you there? Yeah, there you go. Perfect. Perfect. The table is called characters, I think, and yeah, I think you are already on to that. Perfect. So if you run the SQL now, yep, right there, and there you go. Very well done. So we are going to take a look at the result of what that actually returned. And as you can see, the output had this column nationality, but this time around, there are only 4 distinct nationalities in here. As you can see, even though there are 7 actual rows, but there are only 4 distinct nationalities. Asgardian has been repeated repeated twice. American has been repeated thrice, and that's why the repeated instances don't show up on there. So that's why we got Asgardian, American, Russian, and Chinese. So anybody with any doubts regarding this, regarding the distinct keyword? Yeah, Krishna?
Yeah, just I was wondering, one just variety of the thing that, say for example, we have put distinct nationality, which has given different distinct nationalities of each person. But then in that particular same sentence, if we write that select distinct nationality as well as the name, so does it give an error message actually with that, or does it throw some absurd kind
Yes,
of
because what's going to happen is that one of the columns is going to return, so 1, 2, 3, 4, 5, 6, 7. So if we do name and nationality, for example, there are going to be 7 rows generated from name and only 4 from nationality, and that kind of inconsistency, I think, generates an error to the best of my knowledge. And that's why it's recommended you only do that with with one single column at a time.
Right, I get that. Yeah. Yeah, right, thank you.
So I see a couple of people in the waiting room. Okay, I think that has been taken care of. So anyway, everybody good with this lesson? Thumbs up. Okay, perfect. Let's move on to the next lesson. So here we are going to take a little look at how to sort all the results that have been produced using another clause called order by. So just give me a second. Okay, so here seems like someone's a football fan here, probably a Liverpool fan. But so here what they want us to do is they want us to order by surname. And order by, basically, as has been mentioned here, is the act of sorting it based on some column. So yeah, as they say, it isn't just about grabbing our rows, it's also useful for arranging and sorting the order of our results. And we can sort by specific columns and attributes by using the order by keyword. So we can sort the footballers. They have a table called footballers, which has 4 entries. But in this case, as you can see, the player ID is not in the correct order, and that's because everything has been sorted using the surname by using the order by clause. So what's happening here is that they're taking first name and surname from footballers. The result is a little inaccurate because player ID has not actually been mentioned, so that shouldn't actually be there, from this table called as footballers. And it has been ordered by, and ordered by just means sorting, ordered by surname. So when you order by default, it's going to assume that it's in an ascending order. After order by surname, you can specify ascending or descending. By default, it is going to be ascending. So as you can see in here, they have ordered by surname, which is why Trent Alexander-Arnold shows up first, because the surname starts off with an A. Then Harry Kane is the second one because his surname starts off with a K, then S, and then Z or Z, whatever you call it. So yeah, that's why the first one is Trent Alexander-Arnold, then it's Harry Kane, then Mo Salah, and then Wilfried Zaha. So as we just discussed before, we could reverse the order by adding an additional keyword DESC at the end of the query. So because by default it's ascending, you don't really need to specify that. But if you want to change the order to descending, Then after order by surname or order by whatever column you want to base it on, you can add this keyword DESC, which stands for descending, to specify that, oh, you actually want it the other way around, in the descending order rather than the ascending order. So that is just going to get us a result which is in the descending order. It starts off with the first entry in there is Zaha, because the surname is starting with a Z, then S, K, and A, so on and so forth. Similarly, you can order by any column based on numbers as well. Like you can have, I don't know, order by age or something like that, and those will be integers. That would work the exact same way as well. Like if there was another column called as age, then you would order by age, and that's what that would return. And in case of using strings to order, it's going to take the first letter into consideration, and then it is going to put it in an ascending order in that way. So again, no exercise for this one, but is everybody clear with the use of order by? How to order in an ascending order as well as a descending order? Everybody good? Any doubts about order by? Okay, perfect. I see quite a few thumbs ups in there. Yeah, Krishna.
Yeah, in this order by, so can we order by, say, for example, 2 columns? I mean,
yes. Yes,
okay.
Yes. So in that, the first column which you specify is going to be the first criteria with which you order that. And then the second column is going to be the sub criteria and so on. So to give you an example like this, for example, if we had order by surname, comma, first name, and then we had another guy who's maybe called, I don't know, Albert Kane, for example, then what's going to happen is when we are going to print it out, it's going to first print out Trent Alexander-Arnold, because surname is your primary order by parameter, and then it's going to print out Albert Kane before Harry Kane, because A comes before H, and that's how it's going to go.
Yeah. Yes. Absolutely. Right. Thank you.
Perfect. So Evelyn, you had it out as well?
No.
Okay. So I see someone else in there. Perfect. So from lesson 14, for a couple of lessons, I think Nathan is taking over. So what I'm going to do is stop sharing my screen so that Nathan can share his and give others control as well. So after you, Nathan. I don't think we can hear you.
Sorry, just give me one moment. I'm just going to share my screen here. There we go. Okay. So just give me thumbs up. You can hear me. You can see my screen. All that good stuff. Okay. All right. So the next thing that we want to talk about is the idea of using the keyword case. Now, the idea behind a case statement is that we can make decisions. We can have different things happen depending on different scenarios that are coming up. And if you're familiar with programming, then you can think of an if or an else if statement. Very similar, but slightly different kind of a structure. And this allows us to put a little bit of that business logic inside our queries. Now, if we take a look at this query here, the example is that we are selecting an employee's name, and then based off of how the database is set up, it looks like we have an integer called employee level or EMP level that's determining what that employee does. And so what we can do is we can say we have a case when the employee level is equal to 1, and then we provide the literal string of data analyst. Now you can think of this if an analogy that would work for people who are familiar with trains, if you think of how a train track comes into a major city, usually they split off into multiple tracks. And so then depending on how many trains are there, you can have multiple choices. Or think of it as a fork in the road, so you can have choices that can happen. And with case statements, it is possible to have more than one situation happen, but in the example here, that's not what we're doing. So we're choosing one option here based off of what our condition is. So we look here and we have employee level equals 1. That's going to return the result of data analyst. And employee level 2 is middle manager. Employee level 3 is senior executive. And when we run this query, we will get one of those results based off of which integer is coming through from that employee level column. And then if we don't know, if let's say it comes out as a 0 or a 5, or maybe there is no value at all, then we'll get a string back that says unemployed. And you can see here that in this second example, it's structured the same way, but you have employee level 1, in this case is data scientist, level 2 is middle manager, and then level 3 is industry visionary. So you can put whatever you'd like in these scenarios. And in this case, we're using strings, but you can also provide other statements, other columns, things like that. So if we take a look here, just to read out the question. So we love our superheroes, and the same regardless of where they come from. But if we wanted to get a list of their names and their species group in 2 groups, are they a human or are they an alien? Then we could use a case statement. So now what I'll do is bring this down here, and we can see that we have a scenario where we have a variety of different people here, and species is human for a variety of them. But then we have a scenario where there are different species, but we only truly care about those 2 types. So are they human or are they not? And that's what we want to retrieve. So what we'd like to have here is a case statement that looks for the species being human, else they're an alien. And is there anyone who wants to try this one? Hands up if anyone wants to give this a try. And I can try and help you through too if you're not sure. Sure. All right. So I apologize. I haven't actually allowed remote control like this before. There we go. So you should be able to control my screen now.
Yes.
So what we'd like to do, so start off with a select employee name, or not employee name, what is it, hero? It's name, yeah, there we go.
So name.
Yep. Now we need a comma, because the next, we're gonna put our case statement, but that's taking place of a column itself.
Okay.
So now we need...
I will write case.
Case, yep. And then on the next line, we need our first condition. So we'll start with when. And then we want to figure out when species is equal to human.
This may be one of those times where indentation comes in handy to make your code look a little nicer. Just saying.
Yeah.
So do we have to indent?
Don't worry about it.
You don't have to. You don't have to.
Don't worry about it. Just
but we'll look at it after.
So human.
Yeah. And then on the next line, so we only care about the 2 scenarios, right? Or sorry, right there. We need to put a then and then provide the literal string of what we would like the output to be. And I think it was all capital human is what it was looking for. Yeah.
Yeah, human. So then I will write equal to, is it?
So right here, you can just put single quotation mark and just put human in all capitals. Yep. And then on the next line, we need else. And then a single quote. And then we need alien.
That is all, I think.
And then on the next line,
yeah,
we need to finish off our case statement. So we need the word end. And then on the next line, we need to say from and the table name. So it's characters in this case. We should be able to try that. And there we go.
Perfect. The semicolon was missing, which is okay in case of one statement, but I am surprised Nathan didn't catch that.
Honestly, when I'm teaching, well, it depends on the course, but sometimes I don't even introduce the semicolon until much later in the semester. So sometimes I don't even think about it. So you can see.
I've been roasting him about the semicolon way too much now.
Yeah, thank you.
So now if we look at the result that we got here, you can see that we have two columns. We have name and we have the column name here. It's a little bit strange because it says the column name is case when species equal. It literally put our code there, right? But that's essentially the column that we selected. Is there a whole bunch of code that represents the output? And what you can do is you can provide an alias for that, and you can say a single word what that column would be. But in this case, we'll just leave it the way it is because that's how the question goes. But in other scenarios, we could put as, and we can give it an alternate name.
All right. Thank you.
And is there a question?
Excuse me, sir.
Yep.
Can we use other operators other than equal to in case statement, or is
yes, you can.
Fixed syntax?
Yes, you can. You can use any kind of operator that you could use in a where statement or in an if statement, and your expression can be fairly extensive if you need it to be.
Okay, so thank you.
And actually, just to bring back what we had mentioned there, does this let me? Oh no, I can't. So we could do something like this. For some reason, the tab key is not letting me work, but we can do something like that. And we could go as, I guess, kind, maybe. I'm not sure what you would call that question, but you could do something like this, and then it would. Let's see if it comes back.
I think it's in one of the next couple of lessons using an alias.
Yeah. So we'll leave it as is for the moment. Okay, so now the next thing that I want to bring up is that maybe you want to limit the number of rows you get back. So perhaps you run a query against the database. That database table is really, really big. Maybe it's your customers table. It's got hundreds of thousands of customers in there, and maybe you don't want them all. So what you can do is you can limit the number of rows that you receive back, because maybe you're just testing. Maybe you just want to see that things are working. And so what we can do is we can use the limit keyword, and the limit keyword, or the limit clause in this case, allows us to specify how many rows our query is going to return. So in the example that we have here, we can select star from English monarchs where first name equals Elizabeth. And as you can imagine, there would be more than one. But we just want to, in this case, just double check, make sure our query is working properly. And we only want to return one. Or maybe we only want the first result to come back. So at the end of our query, we can put limit 1. And in this case, we're also sorting it using the order by. Now, the most common reason that I've seen this happen is you either want to select the first item of a list after you've sorted it, or maybe you want to select the last item from a list after you've sorted it, or you are selecting from a very large table and you don't need everything, you're just double checking your work. That's usually the most common thing. Now, one danger that I'll point out is that if you're running a query and you don't know how many results will be returned by your where statement, your limit, it might hide that result from you. If you put a where statement in there that's going to return 10 records and you put a limit of 1, you'll only get 1 back. So if you make a mistake inside your where statement, that might be hidden from you and you might not realize that there's a problem. So a limit is maybe something that you add near the end, or unless you're absolutely sure as to what your query is doing. Now, just as a point of reference, so in MySQL, which I believe this website is emulating, you can use top. So you can see in the example here, select top 100 songs from songs and order by record sales. So that kind of makes sense. Maybe it's a radio station. They're trying to select what the top 100 songs are that are most favorite in the current day or week or month. If you're working with a SQL server that's based off of something other than MySQL, so Microsoft SQL, for example, then you would use top in this case, whereas in MySQL we use limit. But the idea behind them is the same. Although, take a look here. Limit is at the bottom. Top is at the top. So again, it's like Windows or Mac. Everything's a little bit different depending on which platform you use. I'll just check out the chat.
Yeah, pretty much like Montreal French and French French.
Okay, so now the next piece that we want to take a look at is counting. And this is part of a larger component, which is also called grouping. And so we can take all of the records that we're retrieving back and we can get some summarization about them. We can summarize that result set in a couple different ways. And maybe we just want to count how many records we have, how many distinct items we have in a list maybe, or maybe we have columns that have numeric values or financial values. Maybe we want to sum them. Maybe we want to know what the lowest number is, what the max number is, the highest number. We want to know what the average number is, things like that. So we have a big list which we want to summarize in some way. And so we can use things like count to be able to help us do that. And in this case, we can use count, which is a function in SQL, and we can count the number of rows in our table. And in the example here, we're using count star. Depending on what the need is for the query, you can count and then you can put a column name in there or some other expression that works as well. But in this case, if we look at select count star from wonders of the world, we'll get a number, in this case an integer, that represents how many wonders of the world there are in this table. So down here in this example, we have a list of people and we want to get a head count of superheroes in our group. And if we want to see just how many superheroes, we don't, again, in this case, we don't care how many, what their names are. We don't care about the details of each record. We only care about summarizing this information. We just want to know how many people are in this list. So is there anyone who wants to try and use count star to retrieve just the number of people in this table here? So hand up if, yeah, there you go. So give me one moment. There we go. So you should be able to control my screen now. Linda is the person I gave access. There we go. So in this case, we'll have select count star from characters. And really, if you think about it, this is probably one of the simplest queries that we would run in this kind of a scenario, and that will give us back the total number of records that we have in that scenario. And we go on to the next section. We can do the same thing, but we can also introduce a where clause. So if we need the count of how many rows are being returned by a specific query, but in the specific case where we have a condition, then we can combine count star with a where statement, and we can see how many records would be returned when our where statement's being applied. So you can see here the example shows that we're selecting count star from Wonders of the World, where located, and we're providing a location. In this case, we're using a literal string, and we're putting Babylon in this case. So we come down to our example, and there's a census happening far away in Asgard, so we need to count how many Asgardian heroes we have hanging out with us. And we only need the number of them. So again, we need to summarize this table, and we only need to know how many are from Asgard, or are Asgardian in this case. So we need to make a select count star from our table, and we need to have a where statement that's only going to include where the nationality equals Asgardian. And can I get a hand up for whoever would like to give this one a try? Sure. All right, you should be able to control the screen.
Yes.
And we need two more components on the first line. So in the first line, we need a select right at the very beginning, and then we need the round brackets around the star. And then no space between the count and the bracket. Yeah, exactly. So in this case, normally in the select, we would put our column names. Well, in this case, count star, well, that is the column name. So that's how that's going to operate. So this is how we would select a count of how many Asgardians we have inside our group here. So we can run that, and I guess it doesn't actually show us the result, but we would get the number 3. So go to the next one. And just give me one moment. All right, so the next component, again, it's more summarization that we're doing. We need to use the sum function. And in this case, we're going to take some numbers and we're going to perform some math on them. Now, the sum function is letting us essentially just add records up. And if we look right here, with this table, we have different players, and then we have caps, and we basically want to add them all up for the entire group of players here in this list. So rather than doing count star, we can select sum, and then we can put the column that we would like to summarize in this case, that we would like to add up the values for, and then we put from, and then we use the table. And we can come down here to this list right here. And in this case, we're looking at the, I guess, the amount of money that each of the heroes has spent. And actually, is that how much they spent, or maybe their costs? So we're going to come down here and we're going to summarize the budget. Now,
it looks like the budget of the film.
Yeah, yeah. Or all the films, I guess, right? So it's not about the price tag when it comes to making these movies, not unless you're a studio executive looking for how big of a check you're going to have to write. I think they should have put how much damage that each character made in the, because all the other ones had to do with the being in world. So let's pretend that you're Marvel's accountant for a second, and you get the total budget for all the Avengers movies. And remember that these budget figures are in millions of dollars. So we need to summarize all of them. So again, we'll look at the example right here, sum, and then the column. So right here, we need to select the sum of budget. And is there anyone who wants to give this a try? There we go. So give me one moment. There, so you should be able to try that. And let's see what happens. Yep, there we go. Oh, it does show the, okay, I guess I just missed that on the previous ones. All right. So there we go. So we get the sum of budget, and so we can see that there was, that's a lot of money if that's in millions of dollars. So select sum from movies. That's where we're gonna get. So we'll try the next one here. And again, more summarization. So we're essentially grouping things together. We're summarizing the results in the tables, and we want, in this case, to get the average. So going through the idea of getting the average, we can take a variety of numbers. In this case, 1, 2, 3, 4, 5, 6, 7, and we can sum them up. So then we would end up with the total of 28, and then we could take how many numbers it was, so we're 7 numbers total, and if we want to get the average, otherwise known as the mean, then we can take 28 and we can divide it by 7, and that gives us 4. So then the average of these numbers would be 4. Now, let's say in the case where we have our players, maybe these are the footballers, we have the wage, and we can use AVG to get the average wage for all of the players. And we can come down here to our example. So we're dealing with the list of movies again, and we're going to look at the list of Avengers movies, and you can see that the amounts on them, they're fairly different. Well, I mean, if you're talking millions of dollars, right, this is quite a bit of money. So you have 220, 250, and then you're up in the 300s and 350s. So we want to know what the average cost to make one of these movies is. And so we need to select the average budget from the movies. And is there anyone here that can give that a try? Okay, So Krishna will give it a try, and then we'll go to the next person for the next one. I see, show answer. That's the piece I was missing. There. So right here we can see we have select AVG budget from movies, and then we're seeing that the average budget for these movies is $286.75 million each. It's quite a bit. And just give me 1 second. So now, again, continuing on with summarizing, we need to figure out what the highest number is. So we can use highest and lowest, min, max. So if you're familiar with Excel, then this is the kind of thing you would normally do in those scenarios. And so in this case, we want to look at the caps for these players, and we want to determine what's the highest cap. We don't necessarily care about who has the highest cap. We just want to know what the highest one is. And then again, we have another query here that's going to find us the lowest cap. And so in this case, we're selecting max, and then we're putting the column that we would like the maximum value from, and from footballers. And this is just going to return what the value of the highest item is. And then when we select min, it's going to give us the value of whatever the lowest record is. Just to clarify, it's not going to give us the entire row. It's only going to give us the number of the highest and of the lowest in this case. So now we've done a little bit of summarizing, and now we can do a little bit of grouping. And we're using count and sum and average and min and max to do summarization of a variety of records that we have. And we can now see if we can group some of these things together. And in this example here, we can see how many players we have in our table. And unfortunately, this isn't really telling us more information about where the higher players overall or of top earning players are clustered throughout the various clubs that exist. So here we can see that we have player names and team, and then we have the player wage. And we can use count to help us figure out how many different players we have in each of the different teams. And so our select statement in this case would look like select team, and then we put a comma, and then count player ID. And we're selecting from players, and then we're grouping by team. So we're doing the same thing that we did previously, except we're including one more column. And what that's going to do is we're going to have one row for each of our distinct teams, and then we'll have a number that represents the count of how many players we have in each of those different teams. And you can see here, the result of this is that we have Barcelona comes up with number of players 2, and then we have 1 for each of the others. And there's one point that I'll make is when we run this query right here, we would get the column title team. And if we were to run this exactly as it is, the column title here would be count player ID. For us to get the result that we're seeing right here, we would need to add a little extra piece to the end of this that would be as number of players, so that we could rename the column title that we get in our result right here. So I'll jump down here. So in this case, we know how many superheroes we have because we did a count previously, but knowing which different nationalities are represented, well, we figured that out too. But we want to know how many superheroes for each nationality we have. So we're going to take a little bit of the queries that we've done previously and we're going to combine them together using a group by. And so in this case, we want to select the count and we'd like to group by the nationality. Now, I'll assign access here. So Prim, you should be able to do that if you'd like to give that a try. And we can just put star even, or you could put ID, that would work as well. So in this case, we actually don't need a where statement. What we can do is we can say group by nationality.
You can need the from too.
True, true. Thank you. I didn't think of that. So focused on the group by, I forgot about the rest of it. So let's try that and see what happens. All right. And I'll go like this. There we go. So we have the select nationality, comma, count star from characters, group by nationality. And that'll give us our list right here, very similar to what we saw previously. And as you can see, as I mentioned earlier, because we didn't put count star as, the title of our column here is literally the function that we used right there. Whereas if we wanted our report to look a little bit, a little bit better, then we could put count star as, and we can say number or something like that. That would make it a little bit easier. So go to the next one. Now I have a whole bunch of little people upstairs who are perhaps requiring my assistance. So what I'm going to do is I'm going to ask and see if Aditya can take over again.
Yeah, that's fine. That's fine by me. I can take over at this point.
All right.
Let me just set up everything. We were on 22, right? Yeah,
yep.
22.
Yeah.
So
there's a link to where we are. There we are.
Just give me a second. I'm just setting up all the chats and all the windows properly. Okay, perfect. So before we move on to lesson 22, can everybody see my screen, hear me properly? Again, just a regular run-of-the-mill technical check. Give me a thumbs up. Okay, perfect. So now we are going to talk a little bit about the having clause in order to filter using aggregate functions. So as we learned before, functions like count, those are the aggregate functions which are there in SQL. And we also learned a little bit about a lot about the where clause. And with where clause, you were able to specify certain conditions which had to be met for the SQL to return that particular row. But in that case, we were specifying conditions based on one column, based on one or multiple columns that already existed in our table. But if we want to specify those conditions in terms of functions, for example, count of some sort, as we learned before, then in that case, we are going to use the having clause instead of the where clause to filter based on the aggregate functions. So first, the from and joins. So joins is something which is lesson 26. So we are going to save it for that point. So when we have the when we want to use the having clause, at that time we are going to do it in the following way. So for example, in their example rather, there is this table called as accounts, and what they want to do is basically select the account type and the count of each account. So basically how many people have that sort of an account grouped by account type. So we just looked at group by before, so everything has been grouped based on the type of account that a person holds, and we are only interested in displaying that or that row being returned if, row as in the collection of rows because of the group by, being returned if the count of all those accounts, again as you can see, count is the aggregate function. So if the count of those accounts is greater than 100, basically if there are more than 100 entries for that particular account type, then only those are going to be displayed. So that's where the having clause comes in. So because we are filtering based on an aggregate function, in this case count, we are using having instead of the where. So let us take a look at an example based on this whole Avengers thing we have been doing. So what you want to do is you want to count the number of superheroes based on their nationality, because there are more than one nationality present. So you want to use the where there are more than one nationalities present, so you want to use the count, group by, and having clause to find all the nationalities of whom there are multiple people present. So there are multiple Asgardians, there are multiple Americans. So those are the only superhero or the nationalities which we would actually care about. So who wants to try and solve this problem? Raise of hands. Anybody who wants to go? So again, just repeating the problem, I might have confused you a little bit earlier, is that we want to find out the number of superheroes based on the nationality, and we are only interested in those nationalities which have more than one as the count. So pretty similar to what has been already done in here. So who wants to take over? So Priyam, I think you went, but I think no one else raised their hand either. So I am going to give you control, and it's been a little while since you went last time anyway. So just going to bring it up to here so that you have an idea. Okay, there you go. The table is called characters. Yeah, you're on the right track. There you go. Select. Perfect. I think those are the only two things we were asked to get. Well, yeah, those can be the only two things. Anyway, from. Perfect. We want to group based on nationalities, and I see some chats popping. Oh, I think David just answered Christian's question. Thank you so much. Having. Perfect. Let's try to, semicolon, good job. And let's try to run the SQL query from below. Oh, something doesn't look right. Try that one again. Maybe remove the nationality. Maybe they just want the counts, but I'm not quite sure. let's try and take a look at that again. Guys, if you see anything wrong with what she has done, please feel free to speak up as well, based on what we had to do.
Yeah, they're expecting to count the star, not the ID, same as the last one.
Oh yeah, count. Yeah, I see that. That's what
you
might
do
be happening.
need
You still,
nationality.
you still do need the nationality. You are
'Cause
absolutely right.
When you do a group by, you can only do a group by. That's something in your select statement. So if it's not in
Exactly.
your select statement, you can't group by it.
That's perfect. That's perfect. That is what was happening. If you try and run the query now, it still didn't work. Okay, just give me a second. Let's see what's happening in here. Count.
So we want to count the nationality, not the ID, on the having clause.
Right. Thank you so much. That count. We want the
So
count.
the count is good there with the star, but on the having clause, we want to.
Oh, that's my bad. Yes, thank you so much. You are absolutely right. I don't know why I was blanking out on that so much. So what we want to count actually is the nationalities that have, like, the group of nationalities. That's what we have done. So that's what we would count. That is perfect. I just had a brain fart in there, and that still doesn't work. Okay, so let's take a look again at what is happening. Group by, we have nationality.
Which one is this one?
The lesson 22. Can't seem to figure out what's happening there. So we have to, okay, superheroes by nationality when there are more than one nationality is present.
What code do we have?
It could just be the order of the select. It's pretty finicky on what it wants. Right answer.
That might be right. So I think it's nationality.
Oh, in count to the bottom, you have to have ID in there.
Yeah. So I think this should work now. I think it was just the order. No.
The bottom one should be ID. The top one, yeah, that'll work. There you go.
Star and star. Okay, sorry for that. Let's just go through that one more time. Just going to refresh that. I was having a few brain farts here and there, but so let's try to take a look at it once again. So first of all, they wanted nationality before the count, and that's why it messed it up a little bit in the beginning. So we start off by selecting columns which they have asked for in that particular order. So we start off with nationality, then count star. Okay, that's what we select from the table called characters. So that's the table in here. And then we want to group based on the nationality again. Nationality spelling. Okay, group by nationality. And then in the having clause, we have to make sure that the count in here is greater than 1. Having count star greater than 1. So if I run this SQL query, then what it has returned is American 3 and Asgardian 2. So finally, after a little bit of confusion, is this clear? Is it clear what's happening in this query? Everybody good? Perfect. So otherwise it would be fine if you change the order, but I think the way they are evaluating the queries we are writing, in that the order also matters. So nationality, comma, count. So we need to make sure that we are putting it in the right order in these kinds of evaluation where the order actually does matter. So so any doubts in that until now, lesson 22? I just single-handedly slowed down the whole class, which was going super fast at this point of time. So moving on to the next bit now.
And I want to apologize for disappearing. I had 4 kids upstairs. They stopped making noise. And so the whole time we were talking earlier, I had one ear trying to figure out what was going on. And then I found out that they made a mess with the milk in the kitchen.
So let's take a look at what null values are now. So first of all, we need to know that null is okay. So so the difference between null and zero, very important to understand. First of all, null does not mean like a minimum value or a zero or anything like that. Null literally means nothing. It's like a void. It is just nothing, and that's all that is. So in Python, you might have seen none. In other programming languages, you might have come across nulls as well. And that's the same in terms of SQL programming as well, SQL programming, whatever you want to call it. Null is basically nothing, not zero. They're very different, as it has already been mentioned. So why do I need to care about nulls, apparently? According to this web page. So as it has been mentioned, like especially if you want to work in data analysis, the nulls can induce a huge bias in terms of what you're trying to analyze. If you try to get an average or something like that, in that case, you want to have a way to handle these nulls. Now, there are quite a few ways to do that, but I think the one that is that we are going to look at later on is coalesce. I don't exactly know how to pronounce that. Coalesce, is that right, Nathan? For this one, but that's for the next lesson. And right now what we are going to look at is how to just exclude the nulls from your result. And what we want to do is just in a where clause, we want to add is not null after whatever after we decide to get whatever columns we want to. So for example, in here, select sum holiday price from holiday. So you basically want the sum of all the holiday prices from there, and we only want to add all those values which are not null, which is why we add this additional where holiday price is not null, which is very important because null can't really be added in there. So in that case, what we are going to do is then take a look at how to use coalesce. And I think, Nathan, I'm going to need a little bit of assistance if possible for coalesce. Honestly, I have never used coalesce myself. Again, the last time I studied about it was in my undergrad. That's when I last used it. So Nathan, I'm going to need a little bit of assistance with the use of coalesce. I think you're muted, which is why you can't really hear you.
Sorry.
So I mean I can try, but I think you'd do a better job of explaining coalesce because I have not used that in many years.
Okay,
I can.
1 second.
Okay.
So basically, the idea here is that we're dealing with null values, and when we think of a null value, it's a little bit different than like a quote with nothing in it, like a string with nothing in it. Think of a null as being the lack of a value. So it's literally nobody typed anything. So if you're going to put a text box on a screen, and you can have a scenario where someone types something in, well, then they maybe put their name in the text box, but then you have a scenario where they put their name in and then they deleted it. Well, technically there was a value at some point, and then you could have a scenario, well, they didn't, where they didn't type anything at all yet. Oh, and Addy, you're still sharing.
Oh, sorry, my bad.
So a null value would be they never put anything at all. There never was a value there. So the idea behind coalesce is that it's going to provide us with the first non-null value in a list. And when we're using the coalesce function, what you do is you put coalesce and then you put a bracket and then you put the first value, comma, the second value, and so on and so on and so on. You can put as many values as you want in there. And then what it'll do is out of everything you pass into it, it'll give you the first value that actually has a value. That's not null.
Not null.
Case. So in this case, it looks like we're looking for holidays taken, and then we're looking for the average. But we only want to include the ones that aren't null, because maybe we have a scenario where there isn't anything specified. So in this case, we can put average, AVG, and then surround it with coalesce, and then holidays taken. And then that will give us that'll give us only the non-null values to be included in our average, so it doesn't mess up our numbering. And you can also use it across multiple columns. So the example down below here, I think this is a much more realistic example that you could have. So you have a list of customers, and you have maybe their name. Then you have a variety of different ways to contact them. So you have a home phone number, mobile phone number, business phone number. And some people will have all three, some people will only have one, some people might have two, but the combination, you don't really know. All you know in terms of your business rules is that I need to contact this person. The most important number to me, it's the home phone number. If they don't have a home phone, then the most important number to me is the mobile phone. And if they don't have either of those, the most important number to me is the business phone. So basically we're telling the database, hey, give me the customer's name. And then of these three columns, home, mobile, and business, give me the first one that the customer actually told us. And just present it to me as phone number. And then I can use that to call them. So in this case, coalesce is going to return the first value that's not null. And if we go down to here.
Yeah.
So what's it say? Nulls really are a pain. Yeah, touche. They kind of are, because if you use a null value in a where statement, you can't even use an equals sign or not equals. You have to use is or is not. It's like, why is it different? Just make it the same, but it's not. So yes, they are a pain. So in this case, we're going to use coalesce to substitute in the character's name if they have a null value for their alter ego name. So in this case, Howard the Duck, there's no alter ego. It's Howard the Duck is Howard the Duck. Mm-hmm. So there's a null value there. So we want to use coalesce to specify the alter ego because he doesn't have one.
So who wants to take control and pretty much in a similar way as this, set up a query for which basically presents to you their name if the alter ego is null. So who wants to take control of that and solve the problem which we have in here? Raise of hands. Who wants to go? Krishna, perfect. Let's give you control again. There you go. Even I got a nice little refresher on coalesce. Thank you, Nathan. Yeah, I would have messed up the explanation because I was myself a little unsure of what it did at this point. But yeah, I just, everything came back.
Well, I had to remember it too because it's been a semester and a bit since I've used it.
Now, since it's an SQL function, you might be better off using it as caps. But again, since that's how you started before. Is that your kids running around?
Yes, it is.
So I think right now we are on lesson 24, right? If I'm not wrong. So yeah, guys, as it's almost 12 o'clock, I think what we are going to do is stop at the nice 5 divisible number of lesson 25, and then I think you have the tools to finish the rest of the course by yourself, and it helps you upskill very nicely. So that's probably that's probably where we are going to stop on lesson 25 for right now. So Nathan just posted the link to the list of lessons. So we are on 25, only 10 more to go. A lot of those have to do with insert, update, delete, and so on and so forth, which is another kind of important thing we have to do. I think you misspelled characters, Krishna.
I had a question there. Nathan, if you could just talk a little bit more about how could null actually create errors in our aggregate functions? Because if we just use from my understanding, if we're calculating sum, null would be considered as nothing, right? So how would it give us an error if we are trying to calculate a sum, or if you're trying to count all the values? Null there just doesn't exist. So how would it create an error in a mathematical function?
So it depends on the SQL database that you're using. So in fact, the example up above for this coalesce, one of the intents of what it's doing is actually providing that to help prevent that kind of an error happening. Depending on the SQL engine that's being run, sometimes it'll treat a null as a 0. Or if you know that you can encounter a null, then you can, in fact, that's one of the reasons you would use coalesce, is to avoid that kind of an error. Or in your where statement, you would include something to exclude the, you would use something to include the, exclude the values that have a null in the one that you're trying to
I just tried to move
summarize.
it. You can take control again. My bad. So yeah, Dylan is absolutely right that, there you go. I think that should work. Oh, that didn't work. Oh, select alt coalesce. Oh, I see what happened. I don't think we had to get the name et al in the first place. That might be me having misunderstood the stuff. Yeah. So here they have mentioned like coalesce, alter ego, or name. So whatever is present, we want that. Like if preferably alter ego, but if it's not, then we just want the name. So for lesson number 24, is everybody clear with the coalesce function? Everybody good? Just give me a thumbs up.
Yes, so just one doubt in that actually. So coalesce, what it is doing here is that alter ego, it will be doing whatever the name it will pull out, but then if alter ego it encounters a null, then it will only pull out the name. Is it? Like
exactly.
that?
So it's like a preference list. This is my highest preference, but if this is not available, as in if this is null, then instead of returning just nothing, it will move on to name.
Okay, I get that. Yes, right, absolutely. Thank you.
Okay, perfect. So yeah, I think this is what worked as well. And for the last I had a word jumble there. I wanted to say for the last lesson, Nathan will take over for today. Yeah, and I think he just took over, and you can do the last one.
Yeah, I just need to remember which screen is which. You can see my SQL screen right there. Just give me a thumbs up. Okay, good. All right. I didn't share the wrong screen. I think maybe I did share the wrong screen. 1 second. Let's try again. That's the one I want. There. Okay, I had 2 open. All right, so the next section here has to do with nested queries. And for anyone who might be in my SQL course, this is something we're going to do very shortly. So it's coming up. So the idea behind nested queries, or sometimes they're called subqueries, is that we can have a query inside another query. So it's like queryception. And we can use them in a variety of different ways to help us do a whole bunch of different things. And you can I'm just thinking about that example I had earlier. Technically, I guess that example that I showed during the break, that's not a subquery, but kind of maybe it's not, technically not. So if we have a subquery or a nested query, then what we can do is in the example we have here, in our where clause, then we can have normally hard-coded values. So in this case, we say where country equals Spain. So that would be us hard-coding a value for the where statement. And we're saying where the country equals a literal string. But that's not very dynamic. And if you think of all the systems that we have today and all of the complexities involved therein, sometimes maybe having things hard-coded, it doesn't allow our software to have that flexibility that maybe we need. And so having the ability to have one component of our software or our system interact or influence another part of our system can make the end result of what we're trying to do much more dynamic. And so in this case, we can see that right here, we have a scenario where we want to search for the lowest priced holiday in our holidays table. But the data changes over time and new holidays get added to the system and time moves on essentially. And the value of the prices and things like that change as well. So here's an example of where we can use a nested query or a subquery to allow us to always return the lowest priced holiday items that we might have. So if you can imagine this table, there are different items in here, and then there's a price for each item. Well, we want to select all of the columns from the holidays table, but we want to select where the holiday price is equal to the result of running this query right here. And it's my annotation. I just want to draw on the screen because I think that's going to be helpful. So it's important to see how we're using our brackets here. And if you have a fluency in complex math, then you'll know that brackets are important depending on how you're doing different calculations. Now, these two brackets here, they are related to each other. They're basically encasing the expression that we have. And if we took the query right here and we executed it on its own, we would get back a price. So you can imagine that doing this would give us back an integer or a decimal, but it would give us back some kind of number that would be the, in this case, minimum price. Now, we're injecting that value into this main query here as our condition. So now our main query, it's a little bit more dynamic. As things get added and change and move around in our database, this query will adjust itself to whatever the most appropriate situation is. Now, this solution would totally work in this case. There are also other ways you can accomplish the same thing. If you think about what we just did a couple minutes ago with our halving statements when we were doing our grouping and things like that, and doing the summarization, technically there's other ways that we could solve this same problem. But I think this does a good job of illustrating how you can use one query inside another query. And you can combine them in many, many different ways. This is only just one very straightforward example compared to the complexity that you can have. And before I keep going, does anyone have any questions about this specific scenario? No? Okay. So now, there's no example for that one, unfortunately, or no trial for that one. So what I'd like to do is just bring it back to what we've been doing for a little bit. And so if we look at this course right here, which we pasted in the chat a couple times, but we'll do it one more time just to make sure. So we have what is SQL, went through that. We did selecting data, and what Aditya has been showing you is that you can select data from a single table. So we've been dealing with single tables here. But SQL is generally used with relational databases. So you have many tables, they're all related to each other. And they can get quite complex. And you can try and select information, and you can join the information from one table to another. And we saw that a little bit when we looked at the, where is it? The case statement. We had a scenario here where we had in our table the employee level, and each employee in this database had a level of 1, 2, or 3. And we're specifying right here, well, 1, it means data analyst, and 2, it means middle manager, and 3, it means senior executive. Well, what happens if there's new jobs available? What happens if there are things change and things move around, and the database has to be a little bit more fluid than that if it's going to run an entire company. And so you wouldn't necessarily see this situation. You would have another table that says, maybe employee types or divisions or departments or titles or something like that, that would have, the titles of each person or each job type that each person in the company can have. And you would need to somehow relate that employee to that position. And when we have our databases, we want each of our tables to be representative of a single entity. And we only want our tables to describe one entity. And so if I'll just open up a database that I use in my class, and just ignore all of the code over here. It doesn't matter. I'm just talking about this right here. So here's a little database that can run a company. You have addresses and administrators and categories and customers, and then we have products and orders and the different things that the customers can buy. And these represent all of the tables. No different than anything that we've been doing so far today. But it's important to see that the products table, imagine that's like an Excel sheet. If you have an Excel sheet or a spreadsheet with a list of products, well, the information on that Excel sheet is going to describe products, right? I mean, it kind of makes sense. And if you have a spreadsheet that describes orders, well, the information on that sheet is going to be about the orders, right? Same thing as if you had another Excel sheet that described maybe the categories of the different products. In this case, it's a guitar shop, so they have different categories. So they have basses and drums and guitars and so on. So the information that's being stored in there describes the categories of the products. Well, in our examples here, we've had a variety of different ones. We have, in this case, employees. And you can imagine that the table employees would describe an employee, right? And we come down to the examples, and we have our table here called characters. And you would expect that that table would describe characters, and so on. Now, we've retrieved data in a variety of different ways from one table. The next step in this journey is to select data from multiple tables. And we finished off right here at 25. The next component that we get into is joining multiple tables together. Building on what we've just done, adding another table to it, adding another level to it. So you can see right here, inner join, left join, multiple joins, union joins, right? And then continuing. And that's what that does. So the next piece is to connect these together. And so I encourage everyone to, continue on, copy that link, and continue on, and try the next piece. And also what I'd like to do is invite everyone. We're going to send an email to everyone at the end with a survey to do, so you can let us know how this session went. And also we have another session that's going to come up in, is it a week that we're doing it? Yeah, so we're going to have another section in a week that's going to come up. And so we'll send you an email about that. And I don't know if David wants to talk about it or if Eddie wants to talk about it. But we'll put that kind of information on there as well. And we would hope to see you there as well. And just to answer the question in the chat there, no, that link to the crash course does not expire. The crash course stuff that we're using, it's actually someone who's a professional who decided, hey, I just want to put this information out there for free. So we have nothing to do with this this website, actually. We just found it and thought it was a great resource. So we thought we'd share it with you.
Sorry, now I'm muted. I should have taken over screen share. There should be a new page open. Okay, so our next event is next week. It's really quick. Addie and I have been talking about some kind of welcome back event for a little while. So this was kind of an impromptu thing that we set up, I think like on Sunday or Monday. So this one came up pretty quick. But this one we've been talking about for a little bit, and we just got confirmation towards the end of this week that our guest speaker at the beginning will be available to come out. So there's no technical requirement for our welcome back meeting. It's going to be a meeting that's going to help us decide what sort of events people are interested in. So if we want to look at more SQL workshops, we can run more SQL workshops. Nathan and I can both run like Android workshops. I mean, we could always touch into iOS development as well. We have contacts that can do iOS development. Web design is a big one that we can touch into. Flutter development for cross-platform is something that we've touched on a lot. Machine learning, I know Addie wants to run something like that. So there's lots of different topics that we can touch into. The exciting part about next weekend's event is we actually contacted the Alibi Room in Sudbury. So we're actually going to be able to get not a technical discussion. I mean, it's going to be a technical discussion, but it's a different discussion than we're used to. So we're actually going to have, I believe, either the owner or one of the bartenders from the Alibi Room, and the website isn't, there we go. Something is running here. Going to come and give us an online lesson on how to make a drink. So that's what I was trying to figure out with Nathan and Addie as they were switching back and forth between who was running it. I was trying to figure out what kind of drink are we going to make? But we need to know who is interested in the drinks by Wednesday. So there's only a couple of days left to grab those tickets. But if you just want to, so anytime after that, or if you don't want to get a little drink pack delivered to you, you can just grab it. You can just grab a general admission ticket. So the rules for the mixology ticket is you have to be 19 plus. That's the drinking age in Sudbury. And you have to live in Sudbury, because I'm probably going to be the one that's driving around delivering drink kits to everybody. So I need to figure out how to find everyone's address and confirm that you are 19. So a couple of days left to grab a ticket for a mixology kit. Otherwise, you can just come to a general admission and help us decide what kind of events we're going to be running. So yes, you can join for general admission if you're not in Sudbury, and then we'll work on hosting general events throughout the year. But if you want to follow along with the ingredients for the cocktail that we're going to be making, you do have to live in Sudbury. But it's going to be an online event, so you can still watch how to make the drink. You just won't have the ingredients delivered to you, because I'm not going to drive to Toronto to drop off just a little pack of ingredients.
So where do we like input the address and stuff on that?
I have to figure that out.
Oh, okay.
I imagine I'm going to be just emailing everybody that's registered and be like, hey,
all right,
where can I drop this off to? And then I'll just like drive around Sudbury really quick and drop them all off.
Oh, cool.
Yeah, that's the part that I have to figure out. I didn't think that far in advance. And then I'm going to also inquire to make sure that the drink could be made non-alcoholic. So I guess really there might be a way that you could follow along and just replace the alcohol with something non-alcoholic. So that might be a possibility as well.
The idea and the execution of this event is completely David's thing, so he deserves all the credit for this mixology idea, which I think is a great way to socialize and talk about tech as well. And for those whom it's the first event of a Google Developers Group Meet, this is basically what we do. We get together, we talk about tech, and sometimes not even tech. We just talk about like many other things, including inclusion, mental health, so on and so forth as well. So for whom it was your first event, I really hope that you liked it, and we hope to see you for the Welcome Back Sudbury event. We have been inactive for a little bit, but now we want to come back and then probably resume at a frequency of one event every couple of months. I'm guessing, David, if I'm not wrong.
Yeah, hopefully at least one per month or one every other month, depending on our schedules.
Right. So I put a couple links in the chat, and ignore the message that I said, please give us your feedback, and I gave a link. I forgot that needs to be emailed to us, so if you try that, it won't work. But you'll get it in your email in a moment. And but if you want to learn more about this or future events, then click on the last link that I sent there. And I'd like to wish everyone a great day, and we'll talk to and hope to see a lot of you in the future. So thank you for coming.
Thank you.
Nathan and Natty will probably stick around and keep talking.
Thank you so much for attending, guys, waking up at 9 on the weekend.
Yeah, especially on a Saturday. It was tough for me to wake up for 9 on a Saturday.
I'm still not awake.
Yeah, I've had 2 coffees and we're slowly getting there.